Hi everyone, this is Mr. West. Today we're doing the absolute value to find distance challenge. This is in Khan Academy. Hopefully you'll learn something from this, and let's go ahead and get started. If W and Q are numbers, which of the following expressions will always be the distance between W and Q on the number line? I think the best way to simplify problems like these are to draw a picture. What really kind of trips up most people with variables is that it's not something concrete. It's hard to imagine a variable. So let's just come up with an example that W is here and Q is here. Now, let's assign some values to this. So as an example, let's say that W is 3 and let's say Q is 7. So it says the distance between W and Q. That was a terrible circle, but we know that we can find the distance by just counting the number of places over from 3 to 7, and that's 4. Another way to get that is 7 minus 3. So at first glance, you might think, okay, C or D might be the answer, but that's not always true. Imagine now, okay, so we knew that positive 3 and 7, we could do W minus Q, and that was an answer. Let's just change up the numbers a little bit. Okay, let's say that Q is negative 7. Let's change this to negative 3. Q is negative 3, and we'll make this negative 5 now for, actually I'm going to change it to green also. We're going to make Q negative 3, and we're going to make W, might as well change both, right? We're going to make Q negative 2, and we're going to make W negative 5. So the distance between these two, we can count over. It doesn't matter which way we count. A distance is a positive value. And we're going to count over 1, 2, 3 times. Obviously, my arrows weren't to scale, but you count over 3. Negative 2 to negative 3 to negative 4 to negative 5. 3 places, okay? So this distance was 3. W to Q in our first example, and the red example was distance of 4. This is 3. But does the same rule apply? Does W minus Q equal 3? Well, we have negative 5 minus a negative 2. That gives us a distance of negative 3. So that is not good there. And furthermore, let's say that we have a third example. I can hardly count. Okay. We have another example where we have W as a negative number. Let's say blue example, sorry. I'm going to leave the green example up here. So we're going to go to a blue example. Let's say W is negative 1, and then we have 4 for Q. Well, W minus Q in this case, we know the distance is 5 between it. But if we do W minus Q, we do negative 1 minus 4, and that would give us negative 5. Again, we'd get a negative number instead of that positive value that we want. So we tried it with a few different methods. We didn't try it with Q as the bigger number. There's still going to be those same issues. So how do you account for that? That's what absolute value does. Absolute value, if you take the absolute value of this, gives us a distance of 5. If we take the absolute value of this, gives us a distance of 3. If we did the absolute value of this, was it 3 minus 7? I can't remember what the first example. I think it was 7. 3 minus 7. I can't remember. But it was absolute value. If you take the absolute value, you get 4. Okay? So no matter what, if we take the absolute value of the difference, you always want to find the difference, and difference means subtraction. So difference equals subtraction here. So A is going to be our answer. This would give us a combined summation there. This would give us something, but we already went that it's going to give us negative numbers if we're not careful. But if we take the absolute value, we're good to go. Especially considering it's absolute value challenge, it probably should be something related to absolute value. Order the following expressions from least to greatest. I like this one a lot. So here we have some values, and we can kind of come close to these values. But we know that A is the biggest distance from 0. The next biggest distance from 0 looks to be C. C looks to be the next biggest distance from 0. And then B is in last place. That's the smallest distance away from 0. I'm saying that because when we take the absolute value of this number, C, it's going to be bigger than the absolute value of B. So we could even estimate this. We could say C is like 1.8. We could say B is 1.5. I'm actually going to write that here. Negative 1.5. This is like 1.8. It doesn't really matter as long as we know that C is a greater distance. And then we can call A is 3.1. Or let's call it 3.2 just to stay a little bit more consistent. So we know that A, and I'll use a different color. We know that A, erase it, I want more space. A is bigger than C is bigger than B. And this is also true. A, absolute value of A, is bigger than the absolute value of C is the absolute value than B, okay? So what's going to be the biggest values? Okay, so if you want to use the decimals, that's probably the easiest way to go. But yeah, so I'll just go ahead and show the easy way for the first couple. So if we did 3.2, we just need to come up with values of each one of these. So we do 3.2 minus a negative 1.5, and then we're going to take the absolute value of that. Essentially, you're finding the distance between those 2 points. The quickest way to do this problem is say, okay, what has the biggest distance in between? That's what absolute value is. What's the biggest distance in between these points? Obviously, B to A has the biggest distance. And you see here, B to A, biggest distance. So we need that one to the greatest. Now, my question is, which one is the greatest? On the left or the right? That'd be good to know, from least to greatest. Okay, so least is on the left, greatest on the right. So that's got to be our biggest distance, okay, because it has that's got to be our biggest value because it's the biggest distance. Our next biggest distance looks like it's going to be B to C. So B to C looks pretty big also. So we're going to put that second. B to C looks pretty big. Okay, next value, we have A and C. What's that distance? Okay, that's a distance. That's the smallest distance. So what about this B? What do we do with this B? Well, this B has a value of negative. It's a negative value. All these are distances. So this one, and this one are distances. And so they have to be positive value. This one's a negative value, so that one's got to be the smallest. Now, originally I was talking about this. This, you could just plug in the values and solve. You can do that. So you could do 3.2 minus a negative 1.5, and you get 4.7. Absolute value of 4.7 is 4.7, okay? You could do 1.8 minus, negative 1.5 minus 1.8. Take the absolute value of that for this one, and you get something smaller than 4.7. But you could do that for each one of these, but I think it just makes most sense to look at the distances and know that B is negative. So we should be good here. All right, next question. Which of the following expressions are greater than h minus g? So we're looking for expressions that are bigger than this distance. The absolute value means the distance between those 2 points. So h and g. Well, just looking here, between j and k is way bigger. So we know that j and k, the difference between those absolute values is going to be way bigger. So we can already start with that. Okay, now we have negative k as an option. So we need to check out negative k. K is at almost negative 4. So we'll call that negative 3.8. So if it's at negative 3.8, a negative 3.8 is going to be positive 3.8. Is that bigger than h minus g? So we actually need to calculate that distance there. That distance looks to be, well, we'll call that 0.9, and we have negative 1.2. So we need to find the distance minus negative 1.2, and we're going to take the absolute value of that. And as you can see, it's not going to be anywhere close to negative 3.8. We're going to get something like 2.1 as our answer there. So we have 2.1 and 3.8. Negative k is definitely bigger than the difference between those two. So we have A and B. None above is definitely not an answer. Last one, select the best interpretation of the following equation. 11 minus y equals 3. Absolute value of 11 minus y equals 3. The distance between 3 and y is 11. Okay? We can just even put this into words. we have the difference because of this subtraction sign. This is a great word problem review here. So we have subtraction, so the difference, or the difference here between 11 and y. But because there's the absolute value, now we're talking about difference went to distance with that absolute value. So the distance between 11 and y, not 3 and y. And then we have this here. Anytime you see that blue, that equal sign, that means is. And then we have the word following, the number following is. So in this case, it's saying the distance between 3 and y. That's wrong because it says 11 and y, so A is out of the picture. The distance between 3 and 11. Okay, again, does that match my purple? It does not. B is out of the picture. It's got to be C, but let's take a look at y. We have 11 and y, the distance between 11 and y, absolute value, difference. We have the is, and then we have the 3. It matches up perfectly. C is our answer. Check it out. And there we go. Where's me? Always cuts me off. Anyway, thanks for watching this video. Hope you learned something about absolute value, distance, and some word problems. Make sure to check out some of my other videos on algebra, algebra 2, even some pre-calculus I'm starting to do. Geometry is a specialty of mine, of course. But thanks for watching. I look forward to seeing you next time right here on Wes Explains Best.